Okay, here we are again with a follow-up of the previous video. After having soldered everything on the board, as you can see now, everything is on there, the fuse holders, the dip switch, so I will resolve it again. The first thing you have to do is put on the IC sockets, or the foot for the LED BarGraph and the IC. This is this piece here. These. The second thing you could do or should do is put in the fuse holders here, but it doesn't really matter if you put first in the resistors, the diodes, the resistor, diode, resistor, diode, resistor, diode, or this one. But what you need to do is put everything that is not as high as the header here, because this one needs to be a little bit straight. So as I told in the previous video, first put in the IC sockets, then the fuse holders, the resistors, the diodes, the dip switch, and last of all you put in these trim pots. Once you've done all this, what I do is turn it around. Let's turn it around like this. I have some clean fluid. This is this here. Yeah, this is to clean up after you use the solder and you have a lot of residue left. So you put a bit of this and you start cleaning. First of all, use goggles, because if it gets in your eyes, it's gonna hurt. It's gonna hurt real bad. Not that I know out of experience, but better safe than sorry. So cleaning it up, using a bit more, and this should solve all the residue of the flux, or how do you call it, what is in there with the solder paste. So this way you can clean it up. Let me get a tissue to get this clean. Okay, get this one cleaned up again. Get this one a bit dried up. Again, this is not necessary, but I'd like to have a bit of a clean surface and a clean PCB with no residue of anything, so we're going to do it again. Put some more on it. I'm going to do it a little bit faster, otherwise this video is also going to take 25 minutes, because I'm a bit lazy and short in time, and I don't want to edit too much of it now, because it's good weather outside and my daily business is consuming a lot of time. So this is, yeah, pretty quick. I'm doing it all. It shouldn't be done like this. As you can see, the brush is dirty again, so there was still some residue left. Dry it up a little bit. Okay, when this is done, what we showed you previously, and we did wrong in the previous video. First of all, you have to take the IC, the LM3914, and if you want to put it in there, watch out for this. Let me see if I can show you. This little half round, this has to be on the bottom. So when you take that one, put it in place. This one is the first you have to put in there, and once it's straight, you can push it in. It needs a little bit of practice, but once you get the hang of it, again, the half round on the bottom. The second one, put it in there, make sure all the pins are aligned. Sometimes you have to work it a bit. Third one, again, the round on the bottom. Oh, I can see one of the legs is a little bit bent in the wrong direction, so always make sure they are pretty aligned. Yeah, it looks good. straight again, put it in there and push it in. And last one, as you can see, due to the transport, this got a little bit bent, so straighten it, because when you want to push it in the IC socket, it will get damaged. This is hard to see for you guys. Straighten it out. It looks straightened. Yeah. Again, watch out for the half round on the bottom, needs to be. Get it in line, push it in. So the ICs are in place. Now we're gonna take the LED BarGraph, which I showed you in the previous video. This one is with the corners cut off. These ones still have the corners in place, as you can see. So again, same story, cut them out. Watch out you don't cut away one of the legs, but this is only necessary if you use the IC sockets and you want them get deeper in there. So I prepare them, put the left side, the text, as you can see, the text on this one, because in this case the plus side is on the side of the text. Again, number 3, cut away the corner. Oh, almost had one of the legs cut off. Yes, put it in the right position. And the last one, in this case, cut away the corners. Yeah, one more to go. Okay. And now get them in place. Again, try to align it a little bit. Sometimes you have to push a little bit on the side, but once it's straight, again, show you the numbers need to be on the left side if you have the board in this direction as it's laying there. I have it. Get it aligned. And oh, that almost went wrong. Same story again. Left side numbers. Straighten it out and push it in. And last but not least, it's in place. And the last thing we need to do now is get the fuses. The fuses in this case, it's not sharpening. This is one of 100 milliamps. I'll do it this way so it sharpens. Put it in place. Okay, get it in there. That's one. Second one. In place. Third one. Oh, I always like to have the text and all the writings in the right place. It's not always easy to work with the little bars, and my fingers are a bit bigger than they used to be. Again, yeah, and push it in. And the last one, get it in place, and push it in, and that's it. And so far, this is the assembled 4S SOC Module version 1.2. The difference with previous versions is, and I'm also going to make the 7S version the same way. The difference is the solder pads of the fuse holders is bigger, so it makes it easier to solder. Also, I have to mention, first solder the fuse holders before you solder the dip switch, because you could be touching it here and melting it a bit. So it's easier accessible if you put in the fuse holders first and then the dip switch as the last before you put in the header. Also, difference is I've put in some diodes, as you can see here. The diodes, they should make sure there is no leakage of amps going that way, and hopefully it makes the PCB operate better, because I had some issues with amps going the wrong way, and it had influence on the view of the LEDs, so it had an influence. Also, I have to mention this resistor here, always on the bottom of the LED bar graph. This is only necessary if you use the SOC module as a 1 bar readout. 1 bar readout means there's only 1 bar going up or down if the voltage of the battery pack goes up or down. You can also use it as a full display. Then you have to, I hope you can see it on this video here, you have jumper 1, jumper 2, jumper 3 and jumper 4 for each channel. If you solder this together, you can use it as a full bar readout. But then again, the consumption of energy goes up, and then the board uses more amps. Later in another video, some more explanation when I test this out. The trim pots, as you can see here, the trim pots, I use trim pots of 50K. So that reduces, this also a difference between all the previous versions of the 7S which I made. This trim pot, these are all 50K, and I prefer these instead of the resistors. I also had, as you can see still here, you can also choose to build in film resistors with a fixed value. But I prefer to have the trim pots, so I can change it afterwards if there seems to be a little bit of a change in it, because what I found out in the 7S version, when I used the fixed resistors, in the first and the second channel there was a little bit of difference between the other channels. So I like to use the trim pots, but it's not necessary for you to use them. You can also change them for resistors, and as you can see, this is called R1A or R1B, R1C and D. So you have the resistors A, B, C and D. If you need to know the values, so turn around the board. On the back side you see a table, and there you can see the value of the resistors I use to have a bit of the same readout. In this case, as you can see, lithium ion, if you want to use it from 3 volts, a readout from 3 volts to 4.2 volts. In my case, the way I use it is with an overcharge indication. Overcharge indication means this LED is going to be the indication. This is a blue one. This is going to show you that you have overcharged the battery, and there's a problem in your charger or in your settings. The other value, turning back on this side, this value is what I got from Jehu, and this is the resistors he uses. But I ramped it up a little bit, the values, because then, as I said before, the board uses less energy and the brightness of the LED is lighter. But I will talk about that in a later video. So for now, this is the assembled 4S SOC module version, the 4S SOC module version 1.2. And in the next video, I will show you what it does and how it works and the values and more stuff like that. Thank you for watching.